folks know something about it. So tonight we're going to be treated to a talk by Klatt, who's the Director of Engineering at McGraw-Hill Engineering. And I'm going to read this so I get it right. And the title of it is Performance and Security Quality Practices in Continuous Delivery. So I'll let him introduce himself and stick around again. We have door prizes and the usual thing. Thanks for coming.
So, it's John Kahn, and I've been working in the software industry on and off since about 1994. And the path that I've noticed along the way has been to essentially figure out how do you more and more cost effectively deliver software with quality. What I'm about to share with you is part of what I've learned over my career. And a big part of that is essentially figuring out how do you reduce cycle times to keep your software into production. A couple of my colleagues are here. They'll keep me honest. One of them worked very closely on our CI/CD pipeline. That's a continuous integration, continuous delivery. For those of you unfamiliar with that. So we'll start off by talking about what our goal is today. So how do we deliver high-quality software on ultra-agile timeframes with modern software engineering capabilities? But before we can get to trying to accomplish this goal, I think first let me offer you a meaningless answer, which is to use continuous deployment. But to get to a more meaningful answer, the real question is, can I get security and performance while I'm at it? So that's what I'm going to try to get to by the end of this talk. A more meaningful answer, though, is to answer questions like, what is software engineering? By the way, I'm hoping to answer these questions as part of this talk. How to make more meaningful change in an organization? How lean manufacturing is in software? Can lean software be synonymous with quality software? And how can we improve cycle time without sacrificing quality? So we'll start with the definition of software engineering. You guys can read this, so I won't read it. But essentially, I like the definition as containing the words systematic, disciplined, and quantifiable. So I've got a few disclaimers. First of all, software engineering practices represent, in my opinion, a cultural identity of an organization. That's just an opinion, but it's something that I closely hold. I believe that the practices that your organization either implicitly or explicitly follows says something about that organization. Engineering practices also imply a level of risk. Whatever your practices are, that speaks to what the level of risk is. Again, implicitly or explicitly, your organization is willing to entertain. Your practices encapsulate your organization's implied risk tolerance. I think that follows from the previous points. And then before making changes, we must really understand what is that implied risk and intended risk, and why do you have your process. If you don't understand that, then anything that I'm about to talk about today is sort of like nice pie in the sky kinds of things. The premise is that we can actually make the changes that are most meaningful to our organizations that improve quality for our end customers. So this there's going to be some code peppered in here. It's not going to be too hard to understand. But this basically says if your risk that is implied is greater than the risk that is intended, then you need to do the right thing and escalate to management or notify people so that, hey, look, we're doing things that don't make sense. And in many organizations, the quality that you are accustomed to through your existing process, if you're trying to change that process and deliver software more quickly, then you need to be able to understand. You can't just say, well, let's stop doing manual testing entirely. Automation is going to take care of all of that, so we don't have to worry about all these things. I don't know, maybe it's possible, but it's not necessarily true. So make sure that the risk that you're taking is understood. So essentially the idea is that when you look at a process, that looks a little bit like a switch statement. the cause for your current process. Why do you do the things that you do? I think it falls into two major categories. I think that there's probably lots of other reasons, but what I'm saying here is that you either are doing what you do because you had some pain in the past and someone said, oh crap, you can't deliver software like that again, so let's put this rigid thing in place, or it's because it was best practice at the time. Well, this is what everyone's doing in the industry standard practice, so let's start doing that. And it's important to understand why you're doing the things that you're doing so that you can actually be in a position to make an argument for saying, hey, we can change this, we can make it better, we can make it faster, we can make it more reliable, but you need to understand why you had that in the first place, because you have, if you don't address those root causes, you don't understand why you did what you did, then you're not going to be able to fix it. So one of the most important disclaimers is that changing cultural identity is hard work. Cultural identity is equivalent to the software engineering practices as we started off. So as you're looking to change your software engineering practices, you really need to consider that cultural identity aspect. And that if you feel like you were trying to introduce a change that requires the organization to work more closely together, to improve its communication skills, all of these things require that you commit to making sure that those cultural elements are addressed as well. So let's talk about some assumptions, enough disclaimers. We have a cohesive organizational desire to change our culture. If you don't have a cohesive desire to change your culture, then you're likely to fail. And maybe you'll learn something in the process. I'm not saying if you can't get a cohesive organizational approach to something, don't even bother. But if you can get it, this is the way to go. Another assumption is that we understand our organizational risk tolerance and implied risk. I mentioned that earlier. It makes sense that we have to understand that first, but this is laying the foundation for how do we do the things that I'm about to talk about.
Con?
Yes.
By risk, do you mean quality risk?
I think it's risk that what you're, yes, quality risk in terms of what is it that you're delivering to that you're going to deliver poor quality to your customer. Good question. Another assumption is the desire to make use of lean, agile engineering practices, because what these do is essentially help you reduce your cycle time in deploying to a production environment. So let me answer one of the questions I started at the outset, is what is the lean manufacturing context? So a lot of the lean practices we're talking about as practitioners in QA, you guys are likely familiar with the Toyota production system. A lot of the work that W. Edwards Deming has done in his distinguished career to identify that how to improve quality for the end customer. Another aspect of lean manufacturing content is understanding the flow of your value streams. And when you start thinking about it from how a Toyota makes its way through a factory, as value gets added, and you're looking at inventory, and we've got all these tires sitting around but not any cars coming in, that seems like waste. These are the principles of the lean manufacturing movement. And what that means in software is that we can start thinking about this. There's a great book by Mary and Tom Hoppendick. If you haven't read it, I'll gladly share the full title. I think it's something like Managing Enterprise Risk or Building Enterprise Software. Don't quote me on that, but I can point you to it. But they talk about reclassifying the Toyota manufacturing system and its process to the field of software. And when you're talking about software, you start recognizing things like having code sitting in QA for a 2-week process to validate the quality of your software essentially translates to the equivalent in the manufacturing context of having inventory. When you think about it, software engineers wrote a bunch of code, they cost a lot of money. The software QA testers, and they cost a lot of money. They're clicking through things. So that ends up adding to the cost of the time and consequently the money that you're spending to get your software to production. Obviously, if you're delivering a quality product, that's time well spent, but it's not necessarily the most optimal path either. And then finally, the lean manufacturing context is also about continuous improvement. And I think that that's something as QA testers, people involved in the QA space, we all have it brings the right harmonious chords when we hear about continuous improvement. So in the lean software context, these get translated into these properties, from eliminating waste, I'm not going to read them all, empowering the team, building integrity, and seeing the whole. So I think it's always good when you're looking on any sort of organizational change, including the punchline we're getting to near the end of security and performance, that we need to keep these in mind as we're modeling our practices. One of the reasons why I'm belaboring a lot of these points is that there is no silver bullet. I can't tell you, oh, here's the formula, you guys just go and create this yourself, or it's not as easy as making ice. Pour the water in, put it in the freezer, pull out ice. It needs to be customized to everyone, which is why we'll be talking about a lot of this stuff. So these are all essentially manifestations of those principles of lean software engineering. So these are just various points. I didn't put them in bullet form because there's no hierarchy, there's no order. But these kinds of principles, avoid building the wrong thing by building small features that are iteratively built. All of these principles are things that help you start to head in the right direction of being able to iteratively and continuously deliver software to production. So another one of my favorites is talking about Conway's Law. So for those of you not familiar with what Conway's Law says, is that ultimately that I want to make sure I get it right. The software that an organization builds mimics the communication structures of that. So the architectures they build mimics the communication structures of the organization. And this is a very insightful observation because in naturally speaking, I mean, you can kind of think about it like in a very basic metaphor of if three of us were sitting on the beach together building a sandcastle, you might say, well, you build that part, and I'll build this part, and I'll build this part. And the tools that this guy's using versus this guy might be building different parapets or different kinds of things. He's got a bucket of this size, and you've got a bucket of this size, and how you communicate with each other, how you're collaborating together can affect the outcome of what it is you're building. And so the insight I feel that comes from this observation is that if you improve your communication structures, if you improve the trust with which your communication is happening within an organization, you're going to end up creating better products. So again, these are more peppered kind of principles that fall out from lean software practices. Advocating for the customer, one of the things you'll always hear me talk about is that we're trying to build better software for our customers. There's no better reason to build quality than to ensure that your end users are not pounding their head against the wall. So one of the things that a lot of teams don't have the skills for is essentially using scientific problem solving. So some of the many things I mentioned here, and by no means is this an exhaustive list, but W. Edwards Deming talked about the plan, do, check, act cycle. That's what PDCA means there. It's essentially one of the core elements to agile thinking is the idea that we instrument the stuff that we do. That is to say, we capture metrics about it, we inspect those metrics, we form a hypothesis, we try to improve on those metrics, and that cycle continues on and on and on. So that's what plan, do, check, act does. Ishikawa diagrams is basically a way of getting to root cause analysis. These are also part of the A3 processor report. A3 refers to the size of European paper that these A3 reports are supposed to be formed on. It's something that, again, W. Edwards Deming, the Toyota production system, essentially went out and said, well, when you have a problem, follow these steps to model it, understand your value stream, talk about the things you're going to try as a systematic way of approaching the problems that you have. And the interesting thing is that when engineers are sitting down and saying, how do I solve this particular problem, if they're not using, some people just have this intrinsic kind of sense. This is probably where the problem is, and their years of experience rewards them. But to solve larger organizational problems, it's not just having that intrinsic sense. This kind of scientific problem solving can be very useful in many contexts, right? So this operates at the cultural change level. That operates at the level of how do we fix this problem where in this component our quality is lacking. And it also helps out even when you're getting to when we had this outcome, why was the root cause that it happened? And in many cases, root cause analysis doesn't go deep enough to understand, well, you know, in a lot of organizations, root cause analysis means, well, Bob failed, Bob was a bad coder, Joe's a bad tester, whatever have you. And I think that anytime you can point a finger at an individual, you've not dug deep enough. And the reason for that is simply the hit by the bus story, right? Now, when most people talk about hit by the bus, they're like, oh gosh, we've got to do something because if Bob gets hit by the bus, then we're going to be, you know, that creek. And so the thing is that you never want to leave it down to a single individual. You should always be looking at if we had a failure, if we had a quality issue, what's wrong with our process. If you can point to the process that enabled that person to fail, when you had peer review, code review, test cases, test case review, what did we miss? That is a we. What did we miss, not what did you do wrong? That's not the right way to run an engineering organization in my mind.
Beer truck. So I had a boss who called it beer truck.
Beer truck.
Get hit by a beer truck.
That might be nice if they maybe calm your nerves with some beer.
Yes.
All right, so let's using these as guiding principles. Then what I would say is define, build, and enforce your software contracts. This is critical to building automation, in my view. It's also critical to building effective software. If you're engineers or you are an engineer and you're not effectively using contracts to say, how do our APIs interact and can I expect this to be rock solid? Now, we expect that in commercial software. If you decide this weekend you want to do a mashup with the Google API, there's no risk that that API is going to change on you. It's basically sacrosanct. And so that's their contract with you. They publish their API and say, this is what it is. If you're building complex software and you're dealing with multiple software teams, they really should understand between the two of them what their contract is. And if that's not formalized, then it's loosey-goosey, and then you're basically inspecting quality, which never does anything other than to say, no, the quality's not here, try again. There's no way you can do continuous deployment to production where you expect a commit to happen, automation to occur, and software in production moments later without having some kind of a contract that's enforceable. And so then if you redefine your defects around that lens, now your root cause comes to this person violated this contract or there was no contract defined, let's go back and fix that.
Question, but do you consider the enforceability on that a defining principle of the culture as well? Because you can say we're going to make this agreement, but then enforceability, I think, also plays into the type of organization that you have, right?
I agree completely. Absolutely. The fact that you might do a root cause analysis and not do anything about it and just be content. I mean, you have to have this devotion. And it's not like a renter's devotion where they call the landlord and say, hey, the water's leaking, whatever, right? And then they just kind of whatever, they don't care. It's not my apartment, I'm moving out next week anyway, right? It's the owner's devotion that says, oh shit. Try not to press, sorry. Oh crap.
Well, food.
All right, please plug your ears for that. So, oh crap, you know, I'm the owner, my home is getting damaged, I've got to do something about this. So if you're not committed to making that change, then you're right. That's a cultural aspect that you also got to address.
On the contract, would you call that a functional requirement, or do you have another name, or just contract?
I'm leaving it abstract because there's a variety of different contracts you can deal with. So you can deal with contracts within yourself as a software engineer, and say, I'm writing unit tests, and that's my responsibility because, in fact, I go so far as to say I'm going to do test-driven development to take the scientific method. For those of you not familiar with what I'm referring to there, with test-driven development, what you're saying is, I'm going to write the test first, and then I'm going to run that test. I'm going to guarantee that it fails, because now I know my test can fail. If you do do it any other way, you don't know that your test will fail, then you don't know for certain that it's going to fail when you need it to. You write the implementation and then your test runs. Now you have applied the scientific method, you formed a hypothesis, you proved it with your implementation, your theory is about your software is good. So it applies to unit testing, it applies to functional testing. So your contract in certain cases might be, what I like about using an agile process like Scrum, for example, is that at the beginning of a sprint, if you have different functional roles, not organizations do, but different functional roles, you might have an SDET that's writing test automation using Selenium, for example. And then you have a software engineer that's going to be building, let's say, a password or a username and password field. We're all kind of familiar with using those, right? So the premise is that at the beginning of the sprint, both of them can sit together and say, okay, what's our contract? And so what they're talking about in that sense is, well, I've got this form field, it's input, type in the password, and then what I'm going to do is give it an attribute. You can use CSS to pull it up by ID. Here's the name I'm going to choose. Okay, I both agree. You both start your sprint, and you're working in parallel. You don't have to wait for the software to be done to then inspect to see if they implemented the password field correctly. It's something you can do in parallel. When the automation test is checked in, the implementation gets checked in during the merge, where you prove that the person in the code review says both of those components are present. Okay, I'm going to approve that pull request, and all of a sudden your automation runs, and if everyone did their job right, it succeeds, and if it didn't, it fails based on a contract. APIs are best for contracts, because automation are rigid, structured things the software needs to consume anyway, so having software test them really makes a lot of sense. And so that's essentially I think the only slide where I've got red text. To be successful in this venture, we need to automate those contract enforcement. So leveraging continuous delivery, shifting to continuous delivery. This is Martin Fowler's definition. Those not familiar with Martin Fowler, he's sort of like one of the gods of software engineering. So this is what his definition of continuous delivery is. So these are some of the principles of again, lean software brought to continuous delivery. So one of the things we want to do is eliminate unnecessary variation. That's build once, deploy many. So what that means is if you're working with Java builds, you have one WAR file that you deploy. If you're talking about building an application container, a lot of software engineering houses are now using technologies like Docker or Vagrant, essentially to encapsulate the full richness of the software. So you build that once and you deploy that same container to every environment. So variation between environments doesn't become an issue. I mentioned strategies to do that. Another one is to use a configuration management database. So technologies there include things like console.io, etcd, or Zookeeper. And what this enables you to do is to inject your values into your given environment instead of, because if you're basically taking that same software component and deploying it to every environment, well, it can't all be the same. It can't all be your dev environment, can it? Well, this is how you're injecting your configuration into them, and that's stored in a configuration management database like one of these. Also, one of the things you don't want to do is put your secrets and passwords. This is a security concern to have them in your configuration management database. There's special purpose databases to support that. One example is Vault. There's also solutions on AWS called their KMS or Key Management Service, I believe. Another thing we want to do is leverage infrastructure as code. So one of the things that we use is a technology called Terraform. It represents infrastructure as code in the following definition. This is all from a company called Puppet that does configuration management and infrastructure automation. So a lot of your DevOps folks will be potentially familiar with this product. So it's a management approach which enables making infrastructure changes more easily, rapidly, safely, and reliably. So the key point about Terraform is that infrastructure as code allows you to say, I'm going to write code that defines the servers that my software runs on. And when it's a script like that, when you execute the Terraform code, it will stand up your dev environment. You pass in a different flag will build in your QA environment. So the beauty is that if you need a new environment, you can even get to the point of having completely ephemeral environments, meaning that once your automation tests run against that environment, you'll just tear that environment right back down. And those of you familiar with the premise of very carefully handcrafting these environments, and it takes months and years to build up and make sure it's perfect, and the QA team has to go through and make sure they do a regression pass on it, make sure it's perfect. You're not doing infrastructure as code. Because at a point where you are doing infrastructure as code, you know you're doing infrastructure as code because your environments are disposable. You can literally throw them away because you know you can get another one just by spinning up new stuff in the cloud, for example. So another key point is to define your pipeline as code. So changes to your pipeline cause a rebuild and redeploy. We use a technology called Circle CI. And one of the factors of Circle CI is that you can check in your Circle YAML file, this is your configuration file for your pipeline, into source code management. So the beauty of this is that if you make a change to that file, it's going to cause a redeploy of your software. If your software doesn't make it into production, then you have to fix it in code. Every time you fix it in code, it's going to rerun all your tests, and you know that every single piece of automation you put in place, from the beginning of the pipeline to the end, when you start talking about pipeline, you start to have this visual picture of the trials and tribulations your software has to go through are documented there, they're concrete and repeatable. And moreover, they are extremely fast, which means that you're starting to achieve that fast cycle time to production.
Excuse me, do you drive that by file timestamps, like nmake? Where, say, if I update the YAML file, it detects an update, okay, I'm going to rebuild it.
Yeah, good question. So what's happening in this case, you could potentially automate it that way.
Okay.
What we're leveraging is the CI part of Circle CI, continuous integration. So as soon as you make a commit against your source code, the pull request is approved, then that triggers an automatic build and deploy. So every commit every pull request is approved, and that's going all over your product, you can get it done. Question. So then the other one is to realize that deployment doesn't mean delivery. This is probably the biggest observation of organizations doing continuous deployment. So the tagline here is use feature flags and test them. Well, let's talk a little bit about, first of all, what do I mean by deployment doesn't equal delivery? So if I'm deploying code to production and it's not good quality, what now? Do I get fired? And the answer is, well, no, not if I put a feature flag around it. And so what you do, and I think I've got a little bit of code in here, which may be too little to read for some of you, but the simplest possible feature flag says, if a feature is enabled called show tax, then run this code, this function called compute taxes. To do, we haven't yet submitted taxes, so this is commented out. I'm not going to submit taxes, I'm just going to compute taxes. So in my first sprint, if the product owner said, I want you to compute and submit the taxes for the user, I say, well, I can't get that done in one sprint. This is the kind of, giving you the summary view of Scrum, right? So I can't do it all. I can do computing the taxes though, would you like me to do that first? And I say, yeah, okay, sprint 1, 2, 3 weeks, you do the compute taxes function, that's ready to go. But wait a minute, I can't show this to customers. All it does is compute your taxes. It doesn't do anything meaningful. That product is not ready to ship. So we put code around it saying, if the feature enabled is show tax, then do this. So what this means as a tester is you need a framework to be able to go into as a manual tester, and you go into production, you maybe put in a parameter into the URL that sets this value on, or you have a testing framework that enables you to manage those feature flags. Maybe it sets a cookie in your browser. There's lots of ways to do it. But you can go in and see, oh, yep, I can do a view source, and I can see once I have a feature flag enabled, that the taxes have been computed. I'm signing off on this. So then the next sprint comes around, they implement the submit taxes function. You can comment that out, and then even then it goes to production. Maybe you're not ready to launch it. Maybe the product owner wants to say, well, I'm going to send a special URL to the CEO or to this group of testers or whatever else and see how they like the feature. Or maybe enable it for A/B testing, which is distinct from feature flags. but it gives you opportunities to dog food your stuff before you just say continuous deployment to production means delivery to customer. And that's not necessarily true. That's what I'm trying to get out of feature flags. So another aspect of deployment and delivery is the adoption of semantic versioning. So semantic versioning is a concept that applies to APIs, and what it basically says is simply the principle of least surprise. No backwards incompatible changes. Any changes requires, any breaking changes requires a new version. So what that means is 1.0 to 1.1. 1.01 means you're doing a bug fix. I'm fixing something I told you is supposed to work that way, so I'm just going to increment the last number. If I'm introducing a new feature to the existing thing but nothing broke with it, I'm creating something supplemental, then I can call it 1.1. But if I'm fundamentally changing my contract, I'm not fundamentally changing my contract. My contract with you, you're using my API, you're using 1.0 or 1.01 or 1.1. You can continue to use that. I'm launching 2.0. I get to do that because I want to build up new features. I need to make some changes to my API, but I'm committing to you, I haven't changed your API for me. What this means is, depending on your organization's willingness to have multiple code bases out there, you might then start goading the people using your old API. Please update. I'm deprecating in this 3 months, 6 months. You need to get off of that version of that API and migrate to something new. Or in certain cases, if I'm not mistaken, Amazon is like this. They say we don't ever deprecate our APIs. If anyone's out there still using it, we know because we have the API keys in our logs, we're going to continue supporting this indefinitely. Another dimension of separating deployment from delivery is the idea of blue-green deployments. And so what this means, the one way to think about it is 2 productions. So you don't have just one production environment, you have 2. You can use a variety of different tricks. I've mentioned some of them here, but the idea is that on sprint 1, you're deploying into the blue environment, but your customers are using the green environment. And then you drain your load balancers when you've deployed your software, because you want to start giving people access to this one. Maybe you completed your manual testing, and then you move people back over it, and then now your other environment becomes a deployment strategy. So this is again why communication is critical, because if you don't have good friends in DevOps that can collaborate with you on making these changes, good luck being able to make this change. As I mentioned, DevOps collaboration, and there's different ways of doing that. So another principle is to always be prepared to roll back. And the way to roll back is by rolling forward. So essentially, if you had a code here that worked, for some reason something broke, you just keep on rolling forward. Take what you knew was good here, and then deploy it again over what was broken. So essentially, because that also would mean you can't make any backwards incompatible schema changes. Schema changes is the hardest part of all this. You're going to spend just a few seconds on it. It's much harder than I make it. I'm not going to just skim right over it, but it's really hard. You have to think about, if I make the schema change, I need to think about several sprints in advance. I need to deploy my software in such a way that I've got maybe more columns than I would have liked in my database schema. And I'm using database triggers to populate the new schema while the old one's still operating. And once I'm convinced that the schema change is working, I can go ahead and move my software to start using the new columns and then drop the old ones. And this could take 3 or 4 sprints to get all that work done. But the premise is that you can eliminate your risk around major changes to your schema by being very intentional about it. And I've been beating around the bush a little bit, people. The first time I saw this, I thought it was people present to me like it was a joke, and I actually don't consider it to be a joke. I don't manually test my code, but when I do it in production. Now, this doesn't mean that we are delivering crappy quality software to customers, and sometimes we're pushing crappy quality to production. I'm not saying that this is a salve for that, but what I'm saying is by separating delivery from deployment, you can get to a point where you are doing your manual testing in no other environment other than production. It could be in a blue environment instead of a green environment. It could be using those feature flags. It could be because if you're testing APIs, you've deployed a new version that no one's using yet. But your test automation can make sure that everything else that you expected to be in place is still in place. Okay, so now we're getting to a little bit of the punchline. What about performance and security? How do we automate that? That seems like it's a little bit harder to pull that off. So let's start with security. So there are many non-CI/CD best practices, and so I'm not going to go into a lot of those details, but they represent things like threat modeling or training for your staff around OWASP or white hat testing, CSRF protection frameworks. CSRF, if you're not familiar with it from a security perspective, is cross-site request forgery, one of the vulnerabilities you've learned in OWASP training. So all of these things are things that you should probably invest in if you're conscious about security in your organization. Because if you're trying to run test automation, you have to rely, or you're relying on automation for speed to production. The quality of some of these tools is not particularly good. You can't substitute in automation something that people did not think thoroughly about. There are ways to fool these tools. So all of these are good and required practices, but these are not build time activities. And my focus here is how do we make sure security is part of our CI/CD pipeline. A lot of the stuff, as I mentioned, is threat modeling is a design phase where you're starting to think about how can the things around us hurt us, how can people use things against us in our software build. Denial of service attacks, for example, to protect against those, you need to think through this kind of stuff. So during deployments, though, we can use a principle called static analysis. And the OWASP project has a static analysis tool, as well as there's lots of commercial ones. There's one many years ago, I think Hewlett Packard's acquired them since, called Fortify. Another one is called Veracode. Certainly there's a large number of vendors out there that do this kind of stuff. So what static analysis is that it determines things like what are your tainted variables. It looks at the execution code paths of your source code, the data flows. And it can tell when you had input come in from a form, you didn't then try to untaint those form values and put those directly in a database, and then possibly use those values again back to the customer, which would be a cross-site scripting vulnerability. It can detect those and let you know about them. It can also generate false positives, so you need to find a way to remediate against them. But so the essential guideline that I'm recommending, this is part of the pattern that I was suggesting, is that every deployment gets scanned. Scans should be fast. It means that the code must also be small. So there's a lot of alignment with building things as microservices as part of this direction to more agile software building. And so why do scans need to be fast? If you have, the way that I kind of look at it is, again, if you're building in an agile way, you're dealing with small teams. And if you have small teams, you've got 5 or 6 developers. And those 5 or 6 developers, or maybe even fewer, but they shouldn't be clobbering each other and walking over each other. And so if it takes 15 minutes for a security scan to run through, 15 minutes, first developer, and that time maybe another developer came in and has another commit on its back, and then another commit, and then another commit. We want the pipeline to be fast enough that stuff can get through in minutes, not in portions of an hour. I know it's kind of the same thing, but I think you get it when I put it down.
Tom,
Yes.
have you tried parallelizing your scans to make them fast enough?
Sometimes you can. So if you have a larger software product, the best way to do that, in my view, is to break it into smaller components. Part of the problem with parallelizing this stuff is that static code analysis needs to have a picture of the full application to draw those code paths and know where the problems are.
You can still parallelize. A little more complicated, but
Yeah, that certainly may be possible. I'm certainly not expert enough to know whether you can really do that. What we're typically looking for is to, the way that we've approached the problem is make sure that the hardware you're running your static code analysis on is beefy enough to deal with it, and also that you're working with the code small enough that it can really fit into what works well with CI/CD. And the principal aspect of it is that if your software starts getting big, then your code coverage starts to go down from a test automation perspective. And so then that means that you're in a much slower cycle anyway, at which point your slower code scans that take 15 to half an hour are not that big a deal. So the third principle is that defects get created and only titled. Now this is important with software scans because for most of us, our defect system is open to just about everybody. That can be particularly sensitive if you're working in a sensitive area. And so it should say there is a cross-site scripting error in this application, and then there should be a link back. So this is the next one. Defect details point to a scanning source system which has restricted access. So anyone who happens to get into your bug testing, defect system can't know some of your deepest, darkest secrets about the vulnerabilities of your product. Next is that remediation should happen in source code. This is part of the CI/CD pipeline concept, that you have to fix it in source code for the scan to run again. And just much like TDD, is this the check and fix and check and fix cycle. And then finally, false positives that are resolved in the console, which most of these tools give you the ability to do, would be documented. You can come back in and say, no, the software said there's a problem on line 43. You can comment that, put a comment in line 43 that says, not an issue because this value is addressed this way or whatever else. And so just merely committing that comment forces the rebuild, because you fix it in your downstream console. Your console is no longer going to be looking at that false positive. So, as I tried to iterate several times before, it's painful if it's all you do. So let's move on to performance. So performance step one, let's first repudiate the idea that performance is a non-functional requirement.
Yay.
That idea. So what does that mean though? So for the premise is that all user stories and requirements must transform performance into a functional requirement. This means that if someone tells you, oh, I don't know about performance, I don't know how it needs to perform, not good enough. So we need to push back to understand, how will this UX be used? If you're dealing with a product owner, it's like, well, I don't know what kind of performance requirements I need, then it's a conversation back and forth. Improve the quality of your communication, right? This is Conway's law between the engineering department, the QA department. If it's up to you to have this conversation, let's push back our product owner and say, how will you use this UX? How will that affect my system and APIs? Now, it's a conversation back and forth. They don't know your APIs, but you know if this UX is shown and is fetching data from this API, that this API is being called. How fast will those APIs need to respond to delight the customer? Clearly, 3 seconds isn't going to cut it, because they're expecting the web page to load in 3 seconds. So probably need something in the dozens or hundreds of milliseconds. So then, how quickly does my database operation need to perform so that API is even successful? So thinking about it along these lines enables you to get to a story with acceptance criteria in your sprint. That this is part of the grooming part of your Agile process, and you say API X must handle a sustained load of 100 requests per second on a single instance with 98% of results returning under 300 milliseconds. And this stuff you know because you've been working with them to understand, well, how many people are going to be preparing their taxes on April 15th? They're going to be using the software that's going to calculate taxes, and that is going to cause this API thing. It's basically a little Excel formula you can punch in, and you'll be able to answer the question by saying, oh, if I have one instance that can handle 100 requests per second, then this is my performance criteria. The beauty about this kind of a story is this is automatable. You can write a software test that will validate that your API represents this kind of performance criteria. And so the notes around this is that code commits need to be rejected if an API or UX story lacks a required performance test. Not everything is going to require a performance test, but you've got to do that inspection. Performance tests may be written in parallel with implementation code. This is a lot like the story I told of the SDEC and the software developer agreeing on a contract for the password form. In the same way, you can sit down and say, okay, you're about to build this API, I'm about to write this performance test, and because you're writing an API, I need to know what is going to get a 200 response from this, what's going to get a 400 response, how am I going to be able to understand that this API is performing at the level I need. Again, that's important from a cycle time to production to avoid the concept of inventory in lean software. You don't want to have work done in one sprint that isn't delivered in that sprint to production ideally. So if you just build it in one sprint and test it in another, you need to create locality to cause. So locality to cause fundamentally means, that's another aspect of performance I'll get to. I think I'm kind of ad-libbing here rather than getting here, but we'll come back to it because I'm going to talk about this in just a minute. So performance concerns can be manifest, meaning the code didn't meet your test requirements, or they can be latent. So this is the part of the code locality. It's probably best to talk about this in terms of an example. So let's say I've written an API, and my requirements, as we just talked about, are it needs to be returned under 300 milliseconds. So great, I'm sailing along, 100 milliseconds, got a lot of headroom. So then we have a few sprints that goes by. We're adding features and functionality. Again, my requirement is 300 milliseconds. Someone puts in a commit, and all of a sudden my performance is around 280 milliseconds. Well, the automation is still running, that's all good, no problems. So then someone else does a commit, adds 5 milliseconds here, 4 milliseconds there. Before you know it, I'm at 300 milliseconds. So one guy does this commit and it adds 1 millisecond to the API. All of a sudden your tests fail and everyone's yelling at that guy, Frank, you broke the bill, what the heck, right? So is it really Frank's fault? No, I would say, if you then go back and say, well, just roll back his change. No, it wasn't Frank's commit. The commit all the way back there went from 100 milliseconds to 280 milliseconds is probably where you need to be looking at. That's probably where your problem is. So when I talk about latent performance issues, even though your API is under the performance controls, you need to make sure that you are looking at your deltas between deployments. So one strategy we're using is to look at the last 3 performance tests, take the average of those, and if you exceed that by 20%, even though you're well under that 300 millisecond threshold, that's also a failure. It forces the software engineer to look at that and say, okay, what are you doing here? Well, I was just adding the user's name to the form field or whatever. That should be a 0 millisecond impact to your page. But he's hitting an API over there that's causing a database lookup that's not in the cache, and all of a sudden you went up from 100 to 280 milliseconds. Fix that, again, back to proximate cost. If you wait until you're past 300 milliseconds, you're toast, because now you got to figure out what caused the problem in the first place.
How do you keep that signal clear as you're adding capability to your system? Because you do have to go get the name, right?
Well, so in that case, you might be asking, well, why did you do it that way? And maybe say, should there have been a better way? Make sure that, because adding something as simple as a person's name to a page should be relatively easy to do without doubling the performance, worsening your performance by doubling, right? So at that point, it forces you to address the problem at the point you created it, rather than having some poor stat who added 1 millisecond to the API deal with that change.
Got a good question.
Yeah.
And if this is off topic, you can push it. But what about test data management as a correlation to performance? How do you plan for that in the context of performance and the continuous delivery, continuous integration roadmap? Isn't that a very key? How meaningful that's going to be is the investment in that.
Test data management?
Right.
I'm not sure I understand exactly what you're saying, but let me ask your question back to you, make sure I understand it. So the implication is that if we're dealing with making decisions like this around performance, we're looking at test data to make those decisions, do we need to be good stewards of that data?
Basically, exactly. Understanding, yes, you have a function, you have a process, you have an end-to-end that does a transaction. So how many of that are iterations? What is the mapping? What is the negative? What is, what's the breadth that you're going to throw at that in a reproducible, meaningful way? Instead of just, yep, it works, let's push it to prod.
Yeah, see, I think it comes back to in the performance realm that where you're defining the performance as a functional requirement. So you should be able to say, if it's going to be a problem in production, I've captured that already in my acceptance criteria and built it. If you happen to miss it, and of course all these values should be written to a database so you can determine those latent failures. Those latent failures are things that still, again, they fit the performance criteria, but it's like a cancer that's growing. can't let that sit. You have to address it at the point you introduced it. And the beauty is the software and the data management you're talking about gets us to that point.
So in your model, it's more test in production, see the latency, see the impact, resolve it, versus seeing a preemptive, this is what I've thrown at it, and I see where it's going to fail, or is it both on the A/B model like you're talking about?
Yeah, thank you for that question. It's actually a really good distinction. I'm not advocating doing your performance testing in production.
Okay.
I'm advocating a stage gate, just like your test automation is happening in QA environments prior to production. Your security is running in a security environment. It's custom built, purpose built. It gets spun up, tests run against that environment. If they succeed, you move on to the next pipeline, which may be building its own test environment, may be instructed with its own performance test data to support that with its own fixtures. So every one of these is part of a pipeline step. The only thing I'm suggesting testing in production when you're at this level of kung fu is to do manual testing in production. Everything else should be automatable prior to that.
Do you do bottom-up testing as well as your end-to-end and unit tests?
So the integration testing, is that what you mean by bottom-up testing?
Well, all dependencies in place, but I'm not going to leave out the GUI part or the client-facing. But you would test, for example, your APIs with all dependencies in place. So for your example, where the name was added to a database field which caused a back-end call that impacted the performance, then a bottom-up test would expose that. And you can run them very fast and often.
Yeah, absolutely. Especially if it's automated. It can be
Right.
part of the automation framework. Absolutely.
Well, that's the idea. Okay, so do you do those?
We do.
Okay, cool. Yeah. Do you do separate performance tests and functional tests? Or do they integrated?
Well, to a certain degree, that they can be. It depends on how the performance test is written. Certainly, if we're performance testing a UX control, then it is fundamentally integrated. If it's based just on an API, then we're just directly hitting that API.
Regarding the performance test, usually you need a different performance lab or different environment to perform the performance test. Usually you combine all the functionality, security, and performance in the same environment, or you have separate environment and perform all the tests in separate environment and then go to production from different environment, or you have a staging environment and then you do it to production.
Yeah, there is no universal true correct answer. It can be any of the ones that you mentioned. I think that what's right for any given organization is often going to be determined by how easy is it to build your environments, tear them back down, bring them back up again. If you're dealing with certain legacy software or integrating with other systems that it's hard to have test your software in isolation, you need to have these environments for integration. They may be long-living environments. You may also have difficulty in terms of getting your data fixtures there to support the idea of purely ephemeral security and performance environments. Another requirement around performance in many cases is that you're looking at production scale hardware, which or services for using the cloud. Those can also be very expensive, and in many cases people build the environments and leave them up and they keep them running for really long periods of time. I think that's not being a good steward of money management, so I advocate towards one of the changes that I would seek in the appropriate environment context would be to try to keep your performance environment so it can't be ephemeral, that it only gets spun up when you're actually doing the deployment, it only runs while your performance tests are running, and when they're done, it writes out its reports and metadata that you need, so that environment doesn't need there anymore. It gets back to some of the test data management aspects.
Avanade, exactly. They're just up for given hours during the time.
Don't keep that expensive hardware services running, just tear them back down again. All right, so the guidelines for performance these are just a recap. All stories must be evaluated to whether, again, these are my guidelines I suggest. There are other ways to do this, so I want to make that very clear. All stories must be evaluated whether performance criteria should be specified. All code must be reviewed for performance that validates the criteria. Performance results must be written to a database or dashboard. Performance metrics not meeting standards are rejected. performance metrics that exceed a baseline threshold, like I said, 20% of the last 3 results, they also fail. And remediations happen. In order to get another performance test, you have to change something in code that's going to remediate the problem and cause the redeployment to occur. Now, I'll go back to that real quick. So remediations happen in source code. If you fix a performance problem without actually touching the source code, then what you're acknowledging at that point, and actually at any point in the pipeline of your SDLC, is that you're saying there's an element that affects my code quality that isn't controlled through my pipeline, right? And that should set off some alarm bells in your head saying, wait a minute, all quality goes through this pipeline. Everything is automated, everything's managed through this pipeline, so I can't allow variations to occur, external factors. The fact that it's a Tuesday shouldn't make my software run, you know? You can't let anything, what the day of the week or anything else, allow you to be sidelined. So in summary, performance test automation in code should be performed by different functional teams, should originate from the same requirements, and start at the same time. If performed by the same individual, no pull request should be approved without validating the performance, test automation, and implementation are all present. So that basically recognizes large organizations where you have separate functional units that you can work from the same requirements to produce quality together, that your communication, your common base laws is suiting your organization, you're talking about what it is that you're looking for in terms of your criteria. And then if you're in a much smaller organization and it's just one person, then hopefully you have a large enough organization that someone else can look at their code commits, and if that same software engineer wrote the performance tests, wrote the unit tests, wrote the functional tests, that the peer reviewer who's approving that code request looks at that code and says, yep, it's all there. I'm convinced that your commit is going to trigger all the right things along the pipeline to get your code to production. And the beauty of this kind of a thing is regardless of what kind of organization you have, everybody is thinking about the full pipeline and how the pipeline ensures quality. So this is the countdown. 7 key points we hopefully agree on by now. We are practitioners of a systematic, disciplined, and quantifiable approach to the full life cycle of software from concept to delivery. We need to understand our organization's implied natural risk tolerance to undertake change with integrity. We seek to drive alignment in our organization of these cultural values in service of the customer. We consider contracts enforceable with automation tests as critical to our quality. We express our engineering practices using a pipeline that exemplifies our systematic, disciplined, and quantifiable approach to deliver value to customers. We ensure that every quality stage gate that can be automated is automated to decrease cycle time to 0 to leverage Boyd's Law. So Boyd's Law, what is Boyd's Law? I'll take a quick sidebar to describe that. So I believe it was during the Korean War that an Air Force colonel, I believe it was, his name was Boyd, was trying to answer the question of how is it that American pilots are more successful than their Russian-trained Korean counterparts. Because they had superior aircraft, had better turning quality, turn radius, had faster speeds, more power to weight ratio. So it was really inexplicable for a long time why it was that the American pilots were besting their Korean counterparts. And what Boyd essentially came to the realization of is we think it's power steering. That in effort, what was happening, and in fact what was happening is that the pilots in the American planes had hydraulic controls, and so they could easily just do this like I'm doing to basically make the plane do whatever they needed to, and the plane just did it. Whereas in the Korean aircraft, what was happening is that you kind of had to pull and to try to make the changes, and after doing that a few times, maybe you got exhausted, and maybe you said, you know what, instead of pulling, I'm going to push, I'm going to do the easy thing, I'm going to go that way, and you could get on top of them and splash them in. So the conclusion to Boyd's Law, which speaks to Agile in so many ways, is simply this, that the frequency of iteration is more important than the quality of iteration. And the way that I think about that is that I tell the story in the following way. Imagine you're on an airplane and the flight control system, the autopilot, is written one of two ways. Either that it is that it has an error introduced once every, let's say it makes a navigational error 40% of the time. That's really scary to be on a plane that's making a navigation error 40% of the time. But the interesting thing about the software is that it's actually checking the navigational instructions every nanosecond. Eventually, if it's making an error that's randomized, it's going to be scattershot. But the 40% of the time, it knows exactly where it's going. Now compare that to another system that is right 99% of the time, but it only checks every 5 minutes. I would be terrified to ride in that latter plane a lot more than I would in the first plane. And the reason for that is that when a plane is coming in for a landing, it takes 2 or 3 minutes to get lined up. And during that time, if you happen to be that unlucky 1%, it's not going to recalculate until you're well past that run line. I would much rather be in the one that's constantly every nanosecond recalculating, because even though it made the wrong decision there, it's going to more than likely correct towards the right direction in just a moment's time. So maybe the 40% is off a little bit, but you get the point that the frequency of iteration can be a lot more meaningful than the quality of iteration. Now, obviously, let's not reject quality in place of frequency, but if you had to choose one, what you want to do is get rapid cycles to production, learn from those cycles, put in remediations. So then the 7th point, we protect our customer from our mistakes by separating deployment from delivery via feature flags, semantic versioning, our goal when we started off was to ask how do we deliver high-quality software on ultra-agile timelines, leveraging modern software engineering capabilities. So the question is, did we achieve it? Any questions?
Yeah, I have a question on your 7 criteria, and to me, requirements is another, it's actually, I look at it from the quality perspective. So you define, the way I would approach it is the way that Goldsmith would approach it is have requirements, have business requirements. This is what the customer wants, independent of implementation. Functional requirements. Now they're measurable because they are tied to implementation, but you need to document those in such a way that everybody knows what you're talking about. It's not overspecified, but there's also very little ambiguity or none ambiguity. So
absolutely.
So that I don't build this, you think I'm building to that subtly different criterion, and suddenly we have a quality issue, or maybe it shows up later. I'm curious if you just track those with the user stories, or if you have other mechanisms.
No, absolutely. I think the user story should be encapsulating those requirements, that the acceptance criteria on those user stories should be fairly thorough and document all of the things that we talked about, from the performance criteria to the contracts that we're enforcing, whether they're API contracts, UX contracts. All these things are in service to the team members doing the implementation, so there's no daylight between what the QA tester, with the SDET, with the software engineer, the performance engineer, the security tester. Everyone should have the same view of what the software needs to do from a functional perspective.
But are the stories traceable to business requirements?
That is a good question. So what I highly recommend is typically when you start with a high-level story, we call them epics. You may have the same language. So those epics, every story that you're working on, again, back to customer value. Why the heck are we doing this? If you don't understand that, you don't have traceability back to requirements, traceability back to that. And the best possible outcome, every commit you're making against your source code repo would have a pre-commit hook that prevents you from committing against that story without putting in the ID of the story that the warranty right in that code. And the beauty of that is that whenever you have a defect, you can actually trace it back to requirements, where you can also say, well, gee, this project is particularly problematic because, again, if you're living a data-driven life, you can start to look at where are my defects happening, why did my source code suck so bad, why did my test suck so bad, you can figure that out and trace it back to where was that introduced.
Okay, sorry about follow-up. So are the epics implementation independent?
I wouldn't say they're independent. I would say the epics are driving your implementation. The epic would be something like, in my tax example, that we need to support this new type of corporation that was created in the federal government guidelines or something.
Okay, yeah, that's implementation.
So that would be a high-level epic that says this is what we need to support. From that, and the product owner is going to be breaking those down into user stories that start to allow you to have something you can deliver in one increment, 2 weeks sprint, for example.
Yeah.
That's nice.
I was wondering what tool set you guys used for like the bug tracking and the documentation.
Yeah, so I'll be very frank and say our documentation I'm not super happy with. We use Confluence, and the thing that I don't really love about Confluence is the search is abysmal.
Right.
Yeah. And it's very difficult to find what you're looking for. So when it comes to I think the software is fine, but I think you really need to make an investment into information architecture about what it is you're documenting. And as part of the Atlassian suite, we also use Jira for bug tracking.
Okay, thank you.
Kind of a comment on your overall presentation. I really like the emphasis on the risk intention versus risk tolerance of the organization. There's a lot of cases that would like to go where you're going, but it can't because of their cultural identity or the risk level. For instance, healthcare IT, whether it's Virginia Mason, Seattle Children's, UW Medicine, all of those are very vendor-driven, specific supportive instances. There's very tight software as an organization, but that's a different model than this enterprise-driven, large. So you have to factor that in, saying, no, it's more important to protect the data and the controls that are in place. And yes, we'll iterate and improve, but that becomes a trump sometimes to software delivery in its most efficient form.
So I would say, even with that, you might want to start iteratively. Like, I think that ultimately it's going to be a competitive advantage for organizations that can do that faster. And so everyone should be shooting for continuous deployment as a strategy. Now, everyone within, as you pointed out, certain risk tolerance, right? Organizations like NASA, for example, have a different kind of a perspective about what a software bug means, because if you've got dead people, that's a completely different kind of story. So a lot of this doesn't apply to that. But if you're trying to increase the agility of your organization, then I would say that you can start with incremental changes, bring in the culture of continuous improvement, inspection, being data-driven, Lloyd's Law, frequency of iteration, how can we improve the frequency, reduce the time it takes to get to production. One of my contexts is that when you talk about the cost of defects, I mean, this was a book by Roger Pressman who first pointed out this principle that the longer you wait until something's in production, the cost starts here, you get to fix it in QA, it's here, fix it in stages here, fix it in production, it's like here. It's a very sharpening curve, right? With CI/CD, you have the exact same curve. It doesn't change. However, it does get squished.
Right.
And when it gets squished, your costs are much lower, and your cost to fix it is much lower. It still is exponentially higher than your lower level, but now that's not necessarily the critical factor anymore. Now you can have frequent deployments to production, but because that overall magnitude is so low, as long as you protect your customer from risk, maybe that's acceptable for your organization to have bugs and blue-green deployments in the product. All right, I think, okay, there's one more question, and then we're going to do a drive.
Yeah.
Go ahead.
I was just, your security, what tool did you use for that?
So we're currently using a product called Veracode.
All right, it's kind of quiet, guys. None of it.